Okay, so we are reviewing for the Chapter 12 and Chapter 13 exam. I literally have the exam sitting right next to me. I'm going to be going through the topics that you need to know for this test. Okay? First of all, what are you given on the test? What formulas are you given on the test? What formulas do you need to know? So I will literally just give you I'm going to write them on the board. I'm going to give you the formulas that are given are basically all of them except for molarity and molality. So we'll start simple. We have our P1V1 equals P2V2. We have our V over T's. We have our P over T. I give you the combined. And I give you ideal. I also give you the constants. So I'll also say 0.0821 liters times ATM over moles times K. And I'll also give you the other constant, 8.314 moles times K. And I'll also give you Henry's law. Okay, that's what you get on the test. Okay? Now, formulas you need to know. Simple. Molarity and molality. So we'll start with molarity because it's more popular. Molarity equals moles of solute over liters of solution, and then molality, which is baby M, is same thing on top, moles of solute, but it's kilograms of solvent. Okay, so the purple is what I give you, the blue is what you need to know. Any questions on that?
Can you write, like, who's who?
What do you mean, who's who?
Like, on the side?
Read the top. Oh, you're saying for the equations. Yes, I can do that. Sorry. Okay, over here we have Boyle. Over here we have Charles. Over here we have Gay. Combined, yep. This one obviously. Ideal and Henry. Good?
Yeah.
Okay, and then molality is just that. So the way that I give it to you on the test is I literally give you a list of all these formulas over here. And I give you the actual formula, but I'm going to ask you, like, whose it is. So that you have to remember. So I give you all of these formulas. You can use them on the test. They're on the board. They're in the test. And you have to say, oh, this is Boyle's, this is Charles, this is Ideal, etc.
Nothing like a matching.
Yes, matching. Exactly. Good. Cool? Any questions on that? Perfect. So I'm going to start from the very beginning, chapter 12. And bear with me as I write because I should have prepared the document before tutoring, but we should be fine. I should be able to get through basically everything. Okay, so I'm going to just separate this over here, and then we're going to start off with chapter 12. So chapter 12 is states of matter and gas laws. Okay. So, what should you know about the states of matter and the gas laws? I'm going to have the PowerPoint up, and I'm also going to have the exam next to me, just so I can give you the most accurate information. So, first things first, you need to know the properties of a gas. Okay? So, everyone should know that gases are, they have... I'm going to ask you. You tell me, what's going on with the shape? What's going on with the volume of gases? Are they definite? Are they not definite with gases? Right. So gases have no definite And shape or just volume?
And shape.
And shape. They take the space of their container, right? Okay, so gases take the shape of their container. They have no definite volume or shape. Okay, they're also easily compressible. That makes sense what I mean, right? So I can compress a gas. If I had a container with gas particles and I wanted to like close this off and like push it down, I would be able to compress all the gas particles in a smaller volume because there's so much space in between them. Does that make sense? Okay. What's up with their particle arrangement?
Random.
Yes. Okay. So the particles they're random, yes, but what else about the particle arrangement? How are they arranged in like a substance? If solids are close together and they're tightly packed, what are gases? Yeah, they're spread apart and they have a lot of space in between. Okay, we'll say they're free floating. And free floating. That make sense? Any questions so far? That's pretty simple stuff. You guys knew this from like what, chapter 2? Yeah, from literally not even. From physical science you knew this. Good. Okay, so that's just the makeup of gas. Okay, next. Let's talk about the kinetic molecular theory. What is the group chat talking about?
They're just reminding you to.
Oh, okay. I'm already recording, I think. Yes, I am. Okay, kinetic molecular theory. So there are some very important parts of this theory that you need to know. Number 1. Let's see. We know that gas particles are hard, spherical, balls, I guess I'll say. Hello.
I got those too.
Oh, hello. Your mom sent you?
No, she didn't call me. I thought you were gonna
Nice.
call my mom.
I wasn't, but I can.
Nah, she would have called you.
Ah. Okay, so I'm gonna erase this actually. Are small, hard spheres that have an insignificant volume. What does it mean, insignificant volume?
It's not like enough.
Right, it's not enough to matter. It's such a small amount of volume that it does not matter. Okay? Yeah, the volume is negligible compared to the total volume. Okay? Next part of the theory, they move in, so I'll say gas particles move in a constant, rapid, linear motion. Right? Okay? They move in straight lines until they collide. Okay, they move in straight lines until they collide with what?
The wall
Either the walls.
or other particles.
Yes. Nice. I'm really like apologizing for my handwriting. I'm rushing. Okay? Another part. Whenever I say that their collisions are elastic, what does that mean? No. They do bounce off each other, but that's not what it means. Collisions are perfectly elastic. Nope.
Oh, they're in a straight line.
Nope. They are, but that's not what it means. So to be perfectly elastic, or to have perfectly elastic collisions, it means that no energy is lost. Only transferred. Does that make sense? No energy is lost. Okay, and then the last one that I want to talk about is there are no repulsive or attractive forces between particles.
Excuse me, is this gonna be like posted?
I could send it to you after I'm done, yeah. Does that make sense what I just said? Those are the 4 parts. So the question literally goes, which of the following is not a part of the theory? And I'm going to take these 4 and one of them I'm going to like change them. Okay? So just make sure you remember that. Okay? So this is very important. So this is one question, and then another question right after that I'm going to ask you about collisions and being perfectly elastic. So that's important. So remember, no energy is lost, only transferred during an elastic collision. Okay? Next. What is the point of the kinetic molecular theory? What does it do? So let's do that. I'm going to say KMT for kinetic molecular theory because I don't feel like writing it. Okay, so the whole point of the kinetic molecular theory is to explain and describe. So I'll say to describe. And I'm going to be reading off the exam, writing exact words for the exam to help you. Okay? The kinetic molecular theory describes exactly how the behavior of gas particles work. Okay? More specific, not just the behavior in general, but how the motion and energy of gas particles in terms of pressure, volume, and temperature. If I put that, you know what that means? P, V, and T. I mean pressure, volume, and temperature. So how the motion and the energy of gas particles, I should say work. It describes how the motion and energy of gas particles work in terms. So let me just change that. Okay. Perfect. All right. Now, let's compare these. Let's look at these formulas and compare some relationships. So I'm going to say relationships between pressure, volume, temperature, and average kinetic energy. You guys know what that means if I were to put that there, right? The average kinetic energy that particles have in a container. This is kinetic energy. Energy of motion. Okay? So, let's talk about the relationship between these 3 variables. Remember, there are formulas that literally help us describe this. If I ask you on the test, if I increase the pressure, what happens to the volume? Would you know how to answer that question? If I said, if I decrease the temperature, what happens to the pressure? If I increase the volume, what happens to the temperature? Would you be able to answer these questions? Exactly. So the formulas will actually give you the answer. Let's look at the first one. Right here. Which formula has P and V in it?
PV.
Nice. How is it written? P1V1 equals
P2.
V2. Perfect. Okay, do you see how these variables are being multiplied? Okay, whenever you have variables being multiplied in like a formula like this is an inverse relationship. So when one increases, the other one decreases. Okay? If I had the formulas written on top of each other, like this, they're being divided. You're with me? This is a directly proportional relationship.
So that means they both increase.
Exactly. So I'm going to say this is inversely proportional. This is directly
Are
proportional.
those terms gonna be on the test?
Not those terms, but it's going to ask you, oh, what happens to temperature when this happens to volume? You know what I mean? So it's going to, well, some of them are going to say, yes, directly proportional. One of them says directly. That's true. Okay? So in this one, this is directly. And when one goes up, the other one goes up, and vice versa. If one goes down, the other one also goes down. Okay? Same thing with the VT formula. V over T. You see how they're being divided, these two things? So then what kind of relationship is that? Exactly.
So when they multiply, it's inverse when they divide.
Exactly. Okay, so if I were to say if volume goes down, what happens to temperature? Right. So you tell me. What can I change this to?
Now.
Hmm? What kind of relationship does pressure and volume have? Inverse. If pressure is increasing, then this must decrease. Okay? Next. Temperature is decreasing. What kind of relationship does temperature and pressure have together? Direct. So if this is decreasing, this must also decrease. Okay? And then this type of relationship between volume and temperature, it's directly proportional. Since volume is increasing, then temperature must be increasing. Does that make sense?
So that does that mean that the T, V, and RT formula is inverse, or is that different?
It depends what you're comparing. PV equals nRT. It depends like which ones am I comparing?
Like since it's multiplied, isn't it inverse?
Well, it depends. If I'm comparing P and V, yes, they're inverse. But if I'm comparing P and T, they're actually
Because it's
direct.
opposite.
Because let's put them together. If I put T together with P, they end up being over each other. So that's direct, yes. Good. Okay, another variable that I can compare is average kinetic energy, the energy of a gas particle. Okay, it's very important to note that the average kinetic energy of a gas particle will increase. This is important. Will increase. I'm going to change the color so we highlight that it's important. When temperature is what? Okay? If I increase the temperature, what happens to the energy? Increasing. So then we have another variable, average kinetic energy and temperature. They are directly proportional. There's no formula for them, but they're direct. So if one increases, the other increases. Okay, and I could ask you about any of these different relationships. Does that make sense? How you would know what's what and what does what? Good. Okay, next. Definition. The second I write this word, you're already going to know the answer, and I want you to say it.
Okay.
Yes. Took a second. With no gas particles or pressure, it's called a what?
Okay.
A vacuum.
Can it have liquid in it? So you have that?
No. Great question. It has to have nothing at all. No type of particle. Great point.
So this, like a water bottle, it would only be a vacuum if there was nothing.
Right, but if I were to try to suck out all the water of a water bottle, guess what? It would just collapse because the container's not stable. I could do that with a with a glass container.
Does the container being stable apply to anything?
What do you mean?
Like, does the container being stable matter at all?
Yeah, because like you can't suck out all the gas of a plastic container because it's just literally
No,
gonna
I'm saying,
crumble.
Is that gonna matter?
Oh no. That's just a fun fact.
Okay.
Okay. I'm gonna give you another definition. Ready? The collisions of atoms and molecules in the air with objects result in blank. Okay, let me give you a hint. When I have the particles colliding with the walls of a container, what does it do? What does it cause? Okay, what does it cause? I have a container, I have particles hitting the wall. What does that build up inside of the container? Pressure. Okay, so if I have atoms and molecules in the colliding in the air, that causes pressure as well. But not just any pressure. Mm-hmm. Oh, I did not spell that right. Atmospheric pressure. This is a verbatim definition.
That's gonna be on the test.
Yep. Everything I'm writing in this document is verbatim on the test.
Are we through the test?
I'm on question 7.
How many questions are there?
44.
I don't know.
That's fine. I'm going to get through as much as I can. When I tell you that whatever I'm writing, all of this is in the Jeopardy game. So if you want me to skip the stuff that are verbatim in the Jeopardy game, I can do that. Or if you want me to just put everything. Okay. Next. I'll try to make it quick. What is the tool used to measure atmospheric pressure? Do you remember the name of the tool? Not thermometer. Close. Barometer.
Oh, there.
You had the meter part. Okay. So barometer measures what? Yes, and more specific, not just any pressure. Atmospheric pressure. Nice. Because you need the air to weigh down on the mercury. So I'll say that. Measures. Because it's a very dense liquid metal. Atmospheric. Yeah, it has it inside. Barometer measures atmospheric pressure. Okay? Conversions. 1 ATM is equal to how many millimeters of mercury?
760.
760 millimeters of mercury. And how much is that? How many kPAs is that? 10?
1.3.
Perfect. This is an exact answer. Okay? What is the SI unit for pressure? You never use it.
PA.
PA. Nice.
Pascal.
Pascals. So, I'm going to say is the...
Is there a conversion factor with kilopascals and pascals? Or
Yes.
Just like the...
Oh, no. King Henry. There's 1,000 pascals and 1 kilopascal.
So you have to divide it.
Right. But I won't ask you conversions with pascals.
Okay.
Wait, we're not gonna have to do the King Henry stuff?
No, yes, but he's saying plain pascals, I'm not asking you. Kilopascals, I'll ask you. Okay? So if I were to ask you, I have 400 kilopascals and I want millimeters of mercury, how would I do that?
Divide.
So I have 400 kilopascals and I always time by a what? What am I looking for?
What you want. 760.
Where does it go? What do I want?
On the top.
Right.
You put
And then the bottom?
And then the bottom is 1 and 1.3.
Yeah, but what unit first? Yeah, and then I get those units from my conversion up here. I have 760 mmHg and I have 101.3 kilopascals. When I do the math here, I end up getting,
Numbers.
I tell you. Oh, wait a minute, we already did this problem. 3,000.987. Okay, I'm going to tell you right now, I'm going to have questions on the test with this as the answer and then this as the answer.
Yeah, the six.
One of them is sig figs, one of them is not. So be very careful. Okay, right here, how many sig figs should my answer have?
3.
Nope.
One.
Yes, 1.
Oh, because of the...
1 sig fig. 4 sig figs. 2 sig figs. 1 sig fig, can 0 round 1? No, it just stays at 3,000. Does that make sense? And what's a unit? Oh, no, you're right. mmHg. Because kilos cancel out, I'm left with mmHg.
It's just 3.
Okay, what if I had like 469 and I wanted 2 sig figs?
Round.
The 6 would round to 47.
I want 2 sig figs. Here's the second. Can my neighbor 9 round 6? To what? My answer is 7? 47? 470. So many of you guys made that mistake on the mole conversion quiz.
Wait, just show.
So you keep that there? The 469, 470.
Yes. Yes. KPA? Kilopascals. Yeah. Okay, next. Do you know what STP means?
STP.
Yeah. Okay. STP conditions. Very important.
We learned that.
Yes, ma'am. standard. I'm looking at it. I said that there's a certain set of conditions that scientists like to do stuff to compare to compare experiment. What is it? Yes, standard temperature and what? Pressure. I'm about to tell you the conditions.
Oh.
Okay, those conditions are 0 degrees Celsius and 1 ATM. Very easy. That's a question. Okay, next. Dalton's law. Dalton's law of partial pressures.
Oh, there's 5 parts, right?
No.
No, that's the kinetic.
Yes. So total pressure is equal to partial pressure 1 plus partial pressure 2 plus partial pressure 3, etc., etc.
No.
So remember, if I have a container, I don't like how it's crooked. Hold on. If I have a container, okay, and I have let's say three different gases. Here's gas 1, here's gas 2, and here's gas 3. Okay? Each of them have their own pressure. That's what it's saying. That's what Dalton's law says. Okay? So we'll say this guy, he has a pressure of 1.2 ATM. We'll say this guy, he has a pressure of 0.5 ATM. And this guy, he has a 0.7 ATM. Okay? So basically, each dot that I drew, each colored dot is a partial pressure, right? So I have 3 partial pressures. And you add them up to get the what? Total pressure. Okay? So then how would I get the total pressure? Yeah. So here, let me recopy this formula.
0.4.
Okay, I'm looking for this equals 0.7 plus 0.5 plus 1.2, and that gives me
2.4.
the
I think.
2.4. Okay, does that make sense? Yeah. And then obviously sig figs, but doesn't matter right now. Just understand the concept. Okay, the sum of the partial pressures equals the total pressure in the container. And I will edit this document and make my handwriting better before I send it to you.
Are you just sending it
Well,
like
you want me to send it only to you, or you want me to send it to everyone?
on
No,
I don't. I'm not stingy like that. Everybody.
Because a lot of us
No.
had AP testing all this week, and then we have
Not
to come
only AP.
from 10.
The other teachers.
Raise your
are
hand to
doing
everyone.
finals.
Raise your hand to send to everyone.
Oh, that's
You guys are funny.
my mom forced me to come.
That's what I'm saying. You guys made the effort to come. Why do they get a cheat sheet and a study guide?
I don't.
You know what I'm saying? But hey, you chose that. You chose that.
Hey, I'm for
If I
everybody.
don't want to come,
You're better than
I
me.
did not want to come. I was about to call my
low-key,
Uber.
I'm not even gonna lie. I'd probably ask one of the kids if I didn't come to
Yeah, they would have gone anyway. Oh, they can hear us. Sorry, guys. Not sorry. Not sorry, actually. You didn't take the time to come to tutoring. Okay, anyways,
Wait, we should.
We're on-
We should get that extra.
Where are they?
We should get that extra credit.
recording.
Wait.
On my
If
iPad.
They can't hear
Or
me.
you're like.
Screen recording.
Just A.
Hmm.
Just A. We should get that extra credit.
I'll see how I feel.
Oh.
If you stay until the end, sure.
Oh, I can't do that.
Well, I'm probably gonna. I'm almost. I'm on question 16.
Honestly, let's go. Come on.
We're moving fast.
It should
All right, next. So I'm not gonna do the problems, but there are partial pressure questions.
But they'll be
Right.
easy.
The same way that I've given you. Remember with the percentages, and then I gave you the
Yeah.
total. You can do that.
Yeah.
Or I give you one
The
partial.
same way you just added up stuff.
Exactly.
Okay.
So I don't have to include that in the document.
Thank you.
I'm gonna say
Percent yield in this test was the
last
last test?
test.
I didn't know that.
I'm tired of school.
You're trying.
You're almost there. Okay, I put right there. There's 2 questions. Only 2 calculation questions. Cool?
Yeah.
Okay, next.
PP.
We already actually kind of
You should change that name.
I'm just gonna do this. So everyone knows what it means. Okay, we already kind of talked about the relationship, so I can skip 18, 19, 20, and 21.
Wait, what?
Oh, you had the test right there, right?
Oh, the relationship between like the partial pressure?
Say it again?
What do you mean the relationships?
Oh, no. I'm saying between volume, pressure, and and temperature. We already talked about that. That's here.
Can we get a free
Increases, one
snack?
decreases?
No. Yeah, exactly. Those are the next 4 questions, which I already talked about. Then I told you, matching. I give you all of these formulas and you tell me which law it is, right?
Yeah.
So I can skip that too. We already talked about that. Okay, next. Now I have 1, 2, 3, 4 problems where you have to calculate using the formulas.
Okay, let's go.
The formulas are simple though.
So, you want me to give you an example?
No.
Yeah, I'd like to.
Okay.
One.
Shut your mouth.
You gotta move it on.
We can be done by 3:30.
I think we can. We're right now on question 26 now.
Shut your mouth.
Uh,
You gotta tell them you're a student athlete.
okay. So, gas laws. Ready? A balloon. I'm going to write out the important information. Fill with 30. What?
35?
Liters of helium at 20 degrees Celsius. At noon. Rose to 45 degrees Celsius. What is the new volume? Okay, so all of these questions, guys, are literally, the calculations are the easiest part.
Yeah.
So, first of all, I'm going to just put a little guide here. Okay, I'm going to write you a guide. Okay, so look at this. Here's my guide. You need to know that pressure can come in multiple units. ATM, kilopascals, and you rarely will see millimeters of mercury. But those are the main units that you're going to use. So if you're given pressure in ATM, you're going to calculate pressure in ATM. Okay? Temperature should always.
Celsius.
No!
Wait,
No!
you're gonna find it in Celsius.
No! Always be in Kelvin. You're going to find it in Kelvin. Yes, what is that formula to find Kelvin? Kelvin is equal to...
73.
You should always plug in a Kelvin temperature into a problem, and you will always get a Kelvin temperature back. You are never plugging in Celsius. Does that make sense? You are always plugging in Kelvin, and you're getting Kelvin back. Does that make sense? Okay, volume will always liters.
Thank you.
But
Milliliters.
if I give you milliliters, how do you convert?
King Henry.
King Henry.
You divide
Okay.
by 100.
Use King Henry died by drinking chocolate milk to convert from milliliters.
You multiply from 100, right?
Yes. Okay, next.
To 1,000.
Say it again.
No.
You multiply the milliliters by 1,000, right, to get liters.
No, divide.
Divide by 1,000.
Divide by 1,000, yes. Okay? Those are my units. You're with me. Oh, and then solubility.
No.
Grams per liter or moles per liter. It could be either one.
Is there?
That's, yeah. But this is gas laws, but this is just in general.
Okay, Miss A.
All right, so let's read the problem. Ready?
Yeah.
A balloon is, I put if. A balloon is filled with 35 liters of helium at 20 degrees Celsius. At noon, the temperature rose to 45 degrees Celsius. What is the new volume?
Hold up.
Wait a minute. One ain't right.
So you don't care about the words. Guys, don't care about the words. Honestly, when I do these problems, I don't even
Do
read
the
it.
BT.
I don't even read it. I just look at the numbers and I look at what it's giving me.
BT. Something with BT. I don't know who it is
It's
though.
V1
Okay.
over T1.
So hold on. I'm given 35 liters. What is that?
Volume.
Okay. Then I'm given 25 Celsius. Okay, but immediately I'm changing that. So 20 plus 273
293.
kelvins. And that's what again? Temperature. And then again, I'm given what? Temperature. Gonna add 273 to that.
Yep.
to get
So
like 3 something, 30,
it's
I have no
35
idea.
divided by
318?
Yeah.
Whew. Temperature. What formula has V and T? You get this list. You get the whole list. You get all of that on the purple. So which one has V and T? This one. I don't give you the words though, so you don't have the people's names.
T1 over T1 equals
Okay.
V2. So it's 330.
So V1 over T1 equals V2 over T2.
So it's 3.0
Wait.
over 293 equals V2 over 3.
So yeah, my volume, first volume is what again?
35
Over?
over 293
Equals?
V2 over 318.
Perfect.
And then you divide.
No, you times.
I want to get V2 by itself. 318 is there. It's being divided. By the way, if you want to just do proportions for all this, you can. You don't have to solve by algebra. So just cross multiply. That also works. If it's in a fraction.
I don't remember.
This times this gives you a number. This times this gives you a number. Set them equal to each other and then solve for V2. Yeah.
Wait, so you can't like divide 35 by 293 yet, right? Can't you?
No.
Like, just multiply?
I mean, you can. Then you multiply by 318, yes. And then multiply by 318. Yes. And then you do, okay, 35 divided by 293.
That's what
I thought you said divided this, like that
no,
part.
No. Yeah, it gives you 37.99.
Yes.
986.
So V2 is equal to 37.98. How many sig figs?
2 6 figs.
Nope.
3.
Yep.
Yeah.
My answer is
37. No, 38.0.
nice. Does that make sense?
That's hard.
So, do you want me to do another one?
No.
You want me to do?
Just put that
I have-
calculator, right? Like
I mean-
times 35
Okay.
over 20.
Yes, but put parentheses if you're doing like, because PEMDAS. Careful with PEMDAS.
How come it's 3?
Because there's 3 sig figs, 3 sig figs, 3 sig figs.
Like 35 times 3 6.
The 0 counts because the decimal.
Shut up.
All right, and guys, this is how all the math stuff is. You just kind of figure out what letters you're given and plug them into the formula.
And then go back.
And you go about your business. That's
Okay,
it.
Miss A,
Let's
So,
say, is there
anything else we need to know?
Oh, yeah. Remember ideal gas law?
Yeah, the NR2T.
Oh, PV equals NRT.
Yes,
Okay.
thank you.
And then if it's ATM,
Wait.
it's 0.
Yes.
8.
I give that to you.
Yeah.
Yeah.
Right?
So you know how to use this.
Yes.
So if I give you I'm giving you 3 moles, I'm giving you 4.3 liters, I'm giving you a pressure of 111 kilopascals,
Right.
and I'm looking for temperature.
Do you want us to use the
PV equals NRT. What would I plug in for P?
11 kilopascal.
111. Okay, and V?
4.3. Then you put equal.
Then you and then you put 8.314.
Okay, good. So
And then you gotta,
there's 2 of them. How do I know which one to use? Look at the units.
Did you use key? So you use 8.3.
Exactly.
You know what the heck.
Yes. This one uses ATMs. This one uses kilopascals. Which one am I using? So I should use what number? 8 point. And then my temperature I'm looking for, and then you can solve by math using this, right? So then you would divide this up. You can multiply it first, divide it off, solve.
Right.
I don't have to do all that, right?
Right.
Okay. Next.
Okay.
Now we're on chapter 13.
Right. Oh Lord.
Wait, chapter 13.
Solutions and concentration.
Looks like you're sitting down.
We're almost done. I'm on question 28.
How many questions are there?
44.
To make you feel better.
No, it's fast. Okay, ready? Question 28. You ready?
Yeah, I'm ready.
Okay. If I can mix
Homogeneous
2 liquids and they dissolve in each other, what is that called?
and miscible.
Yes, miscible.
Wait, what?
When you can mix two liquids together and they dissolve, it's called miscible.
That's a homogeneous,
Right.
mixture.
Okay? If they cannot mix, what is it called? Immiscible. Miscible.
Why make a special word when you can say?
I don't know.
mixable?
Okay? What's this, the substance being dissolved? What is that called? Solute.
Oh, I forgot.
That's important.
And the other one is solvent.
Solute. And then substance
Being the devolver.
doing the dissolving. What is that?
Solvent.
Yes.
Wow.
Oh my god.
Good. Okay? So then I ask you, which of the following examples are immiscible liquids? Select all that apply. I'm not going to tell you what they are, but you're going to select two of them that cannot be mixed together.
Give us one.
Oh, this is common household
us-
items?
Yes.
Or
Okay, I'll give you one of them. Olive oil and lemon juice.
Water.
no.
What?
No, they're
Is it
they're
miscible or immiscible?
immiscible?
Immiscible. Lemon
How am I
juice.
supposed to know
Lemon juice and olive oil don't mix. Lemon juice is water
this?
based.
Well, how am I supposed to know this? What if I didn't know that?
It don't make sense.
Then it sucks.
So now I have to dissolve everything in my house?
It's common household items.
Yeah, I don't do
Be
household
happy
shit.
she doesn't give us helium and beryllium. Sit down.
Beryllium.
Tell him, Layla.
Do you want me to throw
But
this
how are you
lotion at
supposed to know?
You ever ate a salad before in your life?
Yeah,
You ever seen dressing?
yeah.
Then shut up.
You ever seen like lemon and olive oil? They don't mix. They kind of form bubbles.
I don't put lemon and olive oil on my salad.
You want a Welch's bottle thrown at you.
I don't know what's in my salad.
Okay, hold on a second. Lemon juice is water based. Olive oil is oil. We already know that water and oil don't mix. That's why they don't
Juice
mix.
the same.
What's this?
Okay, so
Water and oil.
how
Other
much-
oil.
Okay, what if bleach
Context
and
clue.
bleach and gasoline?
That's different.
How am I
I
supposed to know?
promise you, a 6
That you wouldn't know.
Let's-
Anyways, next question.
Bro, it's not-
Okay? That's the only one that you wouldn't know. The other three you guys would know.
Right.
So I'm not gonna say
So
that.
watch me not know.
You are, and if you don't, then you're dumb. Sorry. I'm serious. It's easy.
I'm gonna ask you these.
Number 30. Determine what. Good luck. Determine whether the following compounds can dissolve in water, right? They either can or cannot.
Okay.
So I give you a list of stuff. Can they dissolve in water?
Yes.
Can they not dissolve in water?
No.
How do you figure that out?
I don't know.
You should know it already.
It's household items again, right?
I thought water was a universal salt.
Oh,
It is.
By
So would it-
moles of
is it-
salt.
Remember, like dissolves.
Like.
Okay, so
it has
polar.
to be polar?
Correct. It has to be polar. But some of this, guys, some of this is literally just straight up like common
Oh, so
sense.
olive is not.
Shut
oil
up.
is not polar,
Oil is non-polar.
and water is polar.
So that's why they don't mix.
Ooh, what's the formula for
Are
it?
you gonna do how to solve for polarity?
Say it again.
Are you gonna do how to solve for like polarity?
I mean,
Yeah, you
the
said-
only ones that you need to know the polarity for, there's only 3 of them.
Okay.
So I'll do an example. Okay. So, like dissolves like. Water is what? Polar or non-polar? So it can only dissolve polar and ionic substances. Remember, not every ionic substance is soluble. You have to look at the solubility table. But I'm not asking you about ionic. Okay, so how do you figure out if something's polar? I'm going to give you one of them. C6H6. I want to know if that's soluble.
That
Yes.
is
You
soluble.
got to draw the Lewis dot structure. What my essential atom is what?
That is soluble, by the way.
The central atom
C.
is
Because it can never be hydrogen or oxygen.
Ooh, this is a bad molecule. C6H6. I have 1, 2, 3, 4, 5, 6. You're with me?
Oh, wait. It's
Oh, this is a really bad. I'm going to change this one.
Please.
Okay. Then I have how many hydrogens? We'll put 1 on each guy, right? Okay.
This is not soluble.
Okay. How many how many electrons does carbon have? Actually, we can do this one. How many? No, we can't.
No, you can't.
Yeah, we can.
No, C is always half of
I don't
6.
think that this is the correct
See,
formula for
It should be
benzene.
C3H6, right?
No, but there's other ones.
But doesn't it go up like that? C3H6. Oh, O3.
Yeah, you guys wouldn't know this. Benzene is actually a ring. So I would have to change this.
Oh, what?
I'll show it. In chemistry, when you go to organic chemistry, you're going to start talking about hexagons like this. No, yeah, in college. This is benzene. That's literally benzene with 3 double bonds. But you, again, I'm going to change this. You're not going to get this. I'm taking it out. Let's say I were to tell you it's like C3H6. So then what would you do? Okay, 3 carbons. No, I want to do 2. 2 carbons. Okay, 1, 2, 3, 4, 5, 6. Everyone gets a hydrogen, right? You're with me? Okay, how do I know if something is polar or non-polar? Well, do I have an equal pull on my central atoms? So on all 6 sides, I have the same amount of pull. Yes, because why? It's the same element. Let's say I took this hydrogen and I put oxygen. Same pull? No, now it's polar. So with this molecule, is it polar or non-polar?
It's polar.
Non.
Oh, what?
Because why?
They get
Equal
I keep
pull.
forgetting that.
Yeah, stop mixing them up.
Equally is non-polar.
So then can water dissolve this?
Yes. No, because water's polar.
Exactly. Thank you. Okay. Go with that?
Excuse me, a second.
Yes.
I have to go.
You can go.
Like, how much time?
I'm on 31.
Okay, Miss A.
I have less. I have less.
Okay.
I'll be literally, I'm not even kidding. Time 10 minutes, I'll be done. Ready?
Bro,
No, hold on. Put it up.
this guy.
Okay. Next. What is the term for the process in which solvent particles surround solute particles to form a solution? Solvent particles surround solute particles to form a solution. What is that? You guys know this. So close. Salvation.
Salvation army.
Yes.
Salvation. That's the process.
The process. So hold on, let me just like edit this.
Dissolving in the solvent. I know that one. You know who taught me that?
Who? He can hear you.
No, you didn't.
The process. Sorry.
Wait, he can hear me correctly?
If he watches the recording,
I love you, Elise.
he was talking so much shit before. Just joking. I'm literally joking.
It's you.
Okay, the process by which solvent particles surround solute particles to form a solution. What is that called? Solvation. Does that make sense?
Yeah.
Okay. Next. What are the 3 factors that increases the rate of solvation?
Agitation, temperature,
Nice.
and surface area. I know that.
Increase rate of solvation. Or what again? Temperature. What's so funny?
I don't know. But I'm laughing too.
Agitation and
Um,
surface area. Good. Okay, what is a saturated solution?
It means that it's too much of the solid.
Yes.
It's because it's too much solid.
Exactly. Okay. Cannot do what? Dissolve any more what? Huh?
Solid.
Dissolve any more what?
You.
Solute.
Then why'd you put saturated solvent? I mean solute.
Oh.
Yeah.
Okay, cannot dissolve any more solute. Yes? That's fine. Okay, what happens in a supersaturated solution if you add a C crystal?
it wakes
boom.
up
It
and it
explodes.
realizes that it can't dissolve anymore, so it starts to clump up.
Woohoo! Okay. Perfect. Supersaturated.
Concentrated, I know that one. Tell me about that one.
Large amount of
Solute.
solute. Wait, supersaturated solution. The excess, so the extra solute that we tricked him into dissolving rapidly, like I'll say crystallizes out because it becomes a crystal. Does that make sense?
Yeah.
Okay.
Super concentrated solution.
Super saturated. Okay. You guys know seed crystal, what it means, right? Speeds up crystallization. Next. Solubility of gases versus solubility of solids at high temperature. What happens to it? So let's start with solids. If I have solid salt in water and I heat it up, is it going to dissolve faster or slower?
Faster.
Right. So solubility of solids at high temperature increases. What about for gases? Decreases, the opposite.
Why?
Because the kinetic energy.
Needs a lot.
Mm-hmm. Okay, so whenever I increase the heat of gases, they want to escape the solution. They want to escape into the air. So they don't stay, they don't stay inside the solution. So they are not soluble. It's like if I have a carbonated Coke and I heat up the Coke, it causes all of the like carbonation, the carbon dioxide, to escape and make the soda go flat.
In dumber terms?
Okay, you have soda.
Yeah.
Soda is fizzy.
Right.
Heat up soda. Leave it in a hot car.
Right.
Soda goes flat.
Because there's okay.
Because the CO2 escapes the solution, it's not soluble.
I get it. No visual learning.
Gotcha. Okay, then I have some one practice problem on solubility. So what's the formula? What's Henry's law?
S1 over T1.
Yes. No. P.
P1.
Yes. Henry's law. There's a directly proportional. Why is it directly?
Because it's dividing.
Nice. It's dividing. Proportional relationship. I'm on 38, by the way. Between solubility and pressure. Does that make sense? So S1 over T,
6, 5.
P1 equals S2 over P2. If this solubility increases, the pressure increases, correct?
Yes.
Direct. And then solubility is measured in grams per liter, or it can also be moles per liter. Does that make sense? Okay. So a solution with large amount of solute. What does that mean?
Concentrated solution.
Mm-hmm.
Oh, yeah. Concentrate.
Okay, so large amount of solute. What did you guys say?
Concentrate.
How about a small amount of solute,
Concentrate.
but more solvent?
Oh,
Diluted. Nice. Okay. Last 4 questions are molarity questions. So calculations
Anatomy.
with moles of solute divided by kilograms of solvent versus molarity is moles over liters solute solution.
Wait, molarity is M?
So this you have to memorize. Does that make sense? There's 5 questions like this. So if I ask you 350 milliliters of a solution contains a concentration of 2.8. What is the amount of moles of solute? How would you solve that?
First, you have to switch it to liters.
First of all, what formula am I using? Molarity. Because why? The liter part and the capital M part. So I have moles over liters. What am I given? Milliliters, which is my volume. And I'm also given concentration. So I can plug in concentration to be what? Do I know the moles? Okay, I'm looking for moles. Moles goes on top. Do I know the liters? Close. I know the milliliters. So then I can use King Henry died by drinking chocolate milk. I'm at milli. What do I want? Okay, here's milli. 1, 2, 3 to the left. 1, 2, 3 to the left. That is how many liters?
0.35.
How do I solve for moles?
Times 0.250 on both sides.
Uh-huh. Moles is equal to a number. I'm going to do that real quick. Nice. Moles. How many sig figs?
2.
It's already at 2. There's no other numbers on the calculator. There's my final answer. Okay, does that make sense? Or I'll give you a more difficult one. Ready?
Difficult?
No, I don't think it's difficult. I think the hardest one that I can give you is
Wait, Miss A, if you go over 10 minutes, can I get a free snack?
no. Maybe if you stay to the end. Okay, what if I gave you this one? I have 250 grams of C2H4, and I'm dissolving it in 948 grams of water. What is the molality? What do you mean?
Okay, hold up.
What am I asking for?
Molality.
What is the formula then?
M mole over kg of solvent. So C2H4.
Okay, what is my solvent then?
Your solvent is water.
Always.
So you want to go from grams to
This
kilograms. So you gotta.
Your timer went off.
Okay, wait. I'm done with this problem and I'm done.
Okay.
You have to move it. King Henry.
Perfect.
Guy King.
Okay, and then this is my what then? If that's my solvent, this must be...
Your salt. You.
Okay, so let's start off with the solvent part, right? I have 948 grams. What do I need?
Kilograms.
So King Henry died by drinking whatever. Don't care about the
You're at
rest.
base.
I'm at base. Okay, which way?
3 times.
To the...
Right.
Right.
Huh?
To the left.
1, 2, 3.
0.948.
So I know my kilograms. What is it?
0.948.
Now what do I need?
You need
You
moles.
need moles.
Okay, what do I
You
have?
need to
Moles
convert.
are gas.
You need to convert.
There you go. I have this many grams of this compound.
24 plus 4.
How can I make him have moles?
28.
What's on top though? What unit?
Moles. 1.
And I'm 1 mole and I'm looking for grams. Sorry, I'm looking for moles. Canceling out grams. Yes, 24 plus 4 is 28. Good.
I can do math.
So then 250 divided by 28.
Exactly.
8.9.
8.928. I don't want to round yet. 8.928 what? So what is that divided by my kilograms? Hmm? What? Sorry. And baby M. How many sig figs? 3. According to this calculation, it's 3. So I have 9 point what is my final answer? Beautiful. Baby M is my answer. Was that so hard?
Is that?
Yeah, Miss A. We wouldn't use the six. Oh, it's
0 is the leading number.
We don't want to round this just yet. If you round too early and you plug it into the formula, your answer will be wrong.
Well, Miss, how about
And it's like,
Oh, you're saying from this?
yeah, we wouldn't use those six.
No, you use the figures from the direct calculations.
Can you put that?
we have 3.
That counts.
Yes.
Please.
Yo, whoever could hear me,
Bless you.
I hate all you guys.
Any questions?
No.
Swear.
Yeah.
Bless.
God bless
Bless you. Was this helpful?
Yes.
And guys, if you guys